Hi boys and girls, today we're going to learn about estimation. We've talked about this a little bit before, but I'm going to teach you a strategy for estimating today, and then some contexts where you can use it. First, let's define what estimation is. When you're making an estimate, you're finding a number that is close to the answer. That would be an approximate answer. Okay, we do not really in all circumstances need to find an exact answer, and sometimes it's more appropriate to find an estimate or something close to the answer. It does involve some easy calculation, which you'll see once we start to learn the strategy. The estimate is not the exact answer, and that, like I said, is sometimes okay. You don't always need to know the exact answer. We talked a little bit about that when we were talking about money. When you're at the store, you can make estimates as opposed to whip out your calculator and type in everything that you're trying to buy. An estimate is a great, handy life tool that you will apply all the time. So the strategy I'm going to teach you today is called front-end estimation. This strategy is usually used for multiplying whole numbers. So if you look at this, 14,923 groups of 782. In this context, we're going to find an estimate, and that's what this symbol means. This symbol means approximately or about. We want to get in the ballpark of the answer. And the way we can do that is by using rounding. So I hope you guys remember how to round. Now, here's where this name comes in. When we're rounding, we create for ourselves a lot of empty place values, which is good. We want to make numbers easier to work with. So we're going to make both of these numbers easier to work with by rounding them off to the front end. What that means is the highest place value. So front end actually means that we're going to round to the highest place value, which actually is, I guess, on the front end of the number, right? The reason being is that we want to have as many empty place values as possible to make the calculation that much easier on us. So if we were to round to this place, for example, the hundreds place, we would have 149,000, and that wouldn't be very easy to work with. On the other hand, if we round to the 10,000s place, which is the highest place value, our number will be very easy to work with. So let's round right here to the 10,000s place, the front end of the number, the highest place value. Well, we see when we look at the thousands place that it is mostly empty, so we're going to clear it out along with all the other place values. And our rounded number is 10,000. Now that's an easy number to work with. We'll do the same thing for 782. We'll round to that highest place value. This package is almost full in the tens place, so we would fill it up and repackage over to the hundreds place. Okay. This place value is irrelevant, so we would clear it out too. We would end up with 800. Okay. Now this problem should look familiar to you. I hope. We worked a lot on these types of problems that have to do with multiplying powers of 10 by multiples of powers of 10. 10,000 is a power of 10. 800 is a multiple of 100, which is a power of 10. So these are easy numbers to work with. So once we multiply those, you can take two strategies to do that. You can multiply 8 times 1, which is 8, and then count what to the what power you're multiplying 8 by, which is 10 to the 1, 2, 3, 4, 5, 6 power. So 1, 2, 3, 4, 5, 6 power, and then add in your commas. That's one way to do that. Or you can take your 800, right, add a decimal place in there, and move and shift that place value 10 to the 4th times, right? So we're going to shift that 10 to the first, 10 to the second, 10 to the third, 10 to the 4th, and then fill those placeholders. You get the same answer, but those are just two strategies. So if we were multiplying 14,923 by 782, we would expect to get about or approximately 8 million. Okay, and that would come into use for us. Maybe if we did the problem, we could cross-check our answer with our estimate to make sure that it was in the ballpark. And that was very helpful. Let's do one more example together for this 4,877 times 9. Again, we're using front end estimation. That means that we are rounding to the highest place value to make our number super easy to work with. Okay, so we would round 4,877 to the nearest 1,000, right? Look at the hundreds place. It's almost full. So we're going to fill it up and create a package in the thousands place. Clear out those places. So we end up with 5,000. Okay. Now let's talk about this. 9 is already a number that's really easy to work with. This appears that it doesn't need to be rounded off to make this a simple problem. So I'm just going to leave that 9 how it is. And look, we have a great problem that involves just multiplying by powers of 10. 5 groups of 9 is 45. And it looks like we're multiplying that by 10 to the third power. 1, 2, 3. So for this problem, we would expect our answer to be approximately, not exactly, but in the ballpark of 45,000. Our answer could be more than 45,000. It could be less than 45,000. For this particular problem, because we rounded up, I would expect our exact answer to probably be less than this because we rounded up. So again, the steps involve 2 skills that you already know how to do, right? One of them is to round both numbers to the front end or to the highest place value. As you can see in this problem, for example, the highest place values in either number are different, and that's okay. The highest place value in this is the thousands place, which you would round to, and the highest place value in 14 is the tens place, which you would round to. So it's just the highest place value in each of the factors. The second step would then be to, well, let me just round it off really quick. The second step would be to multiply without, I'm going to say it, donut disease. Okay. All right, so let's talk about a couple of ways to apply estimating, again, with these whole numbers. So let's take a look at these problems. We can use estimation to assess the reasonableness of an answer. So is my answer in the ballpark? If not, then I somehow made a mistake along the way and probably have to retry. So I'm going to do this problem really quick. I'm going to make a mistake, and then I'm going to use estimation to assess its reasonableness. So let's see. 6, 28, plus 3 is 1. Add. Okay, so my answer is 13,000. Now a lot of students will stop. Done. But really, you should have cross-checked your answer with the estimate. So let's make an estimate here. Let's round 845 off to the highest place value, which would be 800. Let's round 79 off to the tens place because that's that number's highest place value, which would be 80. And let's multiply. Well, 8 groups of 8 is 64. And it looks like we're multiplying that by 10 to the 1 to third power. 1, 2. Now, let's take a look. This is what our number should be around. Our answer should be around 64,000, but it is nowhere near 64,000. So we must have made a mistake somewhere along the way. And that is a great skill. If you're cross-checking your estimate with your answer, you can pick up on mistakes and give it another go. So this is incorrect, and I would retry it. Let's take a look and see if this one's reasonable. Okay, I'm going to do this the right way this time. So 9 times 2 is 18, plus 2, 9 times 9 is 81. 83, hold my place value. 1 times 3 is 3, 1 times 2 is 2, 1 times 9 is 9, and then let's add it all up. Okay, so my actual answer is 17,537. Let's cross-check that with our estimate to see if it's reasonable. Is it in the ballpark? All right, let's round off 923 to its highest place value. its highest place value is the hundreds place. So that will become rounded off to 900. We clear out these place values. And we're going to round 19 to its highest place value, which is the tens place. So it looks like we're going to be rounding up and packaging over. Okay. Well, let's go ahead and multiply these two numbers, 900 groups of 20. So we'll do page 9 groups of 2, which is 18. And then it looks like we're multiplying 18 by 1, 2, 10 to the third power. 1, 2, 3. All right, let's go ahead and compare the estimate with the answer I have. Now these are generally in the same ballpark. 17,537 is pretty close to 18,000. So this answer is reasonable. Okay, as opposed to the other, which was not reasonable at all. So that's one strategy you can use to look at your answers and say, hey, is it close to the estimate? Another thing you can do is use estimation when an exact answer is definitely not needed. Okay, let's look at this word problem together. It says, 58 people are invited to the party. You're going to the store to buy supplies. You figure that each person needs 2 cups, 2 plates, and 3 napkins. Okay. Imagine that you're at the store. I mean, it's not reasonable to think that you would be calculating this on your calculator when it can be so easily mentally done. Okay, so this is what you figure each person will need, and 58 people are coming. What we need to do is round off 58 to its highest place value. So if you round 58 to the nearest 10, the answer is 60. That would be the rounded answer. Okay, so let's use 60. So we want 60 people to have 2 cups each. We want 60 people to have 2 plates each. And we want 60 people to have 3 napkins each. Okay, so now all it takes, guys, is easy multiplication. 60 twos. Well, 6 times 2 is 100, or so 12. Then we have that extra 10 here, so 12 tenths. So you would go to the store and try to purchase 120 cups. About 120 cups. For the plates, you can see it would be the same answer, right? 2 groups of 6 is 12. Tens is 120 plates. You know what the thing is here, guys, is that you're not going to find the exact amount of cups or plates or napkins in the packages that come at the store anyways. So it would be more appropriate to use an estimate for that reason too. And over here, 6 groups of 3 is 18. 18 tens is 180, and that would be the amount of napkins that you would need. Now in this context, you don't need an exact answer. An estimate is a lot more appropriate. All right. Good luck estimating.